Hello. So let us look into the other aspects of the pericyclic reaction. Let's discuss some of the common features that you see in the pericyclic reactions. So first thing is that they are concerted reaction. Now, what do you mean by concerted reaction? You might have heard this particular terminology for quite some time. Okay, concerted means everything is happening in a single step. So as we looked into three types of electrocyclic reaction, there we came across the fact that the electron reorganization is all happening in a single step and via a single cyclic transition state, and there is no intermediates that is formed during this pericyclic reaction. So that is a very common feature that you saw in all the different types of pericyclic reactions. Second important feature that you see is the stereoselectivity. So this I briefed up in the conclusion of the previous video, that these reactions are highly stereoselective. Now, the stereoselectivity you might have seen in other reactions also, where you got some major products and then minor products formed stereoselectively. That was observed in some of the reactions that you might have tried to talk about, like the addition of bromine to double bond. Okay, so those were stereoselective reactions leading to some products that are formed in a larger proportion in comparison to other products. Okay, but the stereoselectivity that we are going to talk about in the pericyclic reactions, as you will see when we talk in details about these reactions, is the fact that the selectivity is like very much near to the selectivity that you can see for an enzymatic reaction. That means no other byproducts are formed in the process, but the only required product is formed during these pericyclic reactions. That is the beauty of the pericyclic reaction. That is also one of the important thing why it took long time for actually theoretically correctly predict or reason out why these are so much stereoselective reactions. Another important feature of pericyclic reaction is that they are not affected by any kind of catalyst or change in solvent. So that you can understand, because often the catalyst are the metal species and they involve in kind of interaction with charged species. So as I told you previously, that pericyclic reaction doesn't involve any charged species. That's why you do not see the effect of catalyst or the effect of solvent, because solvation will come into play only when you have charged species involved in your reaction. So since we do not have any of them involved here, we don't see any involvement of the catalyst or any effect of the catalyst or the solvent in these reactions. Now, this also I pointed out in the previous videos, the fact that these pericyclic reaction very much depends on the configuration of the reactant. Okay, so suppose sometimes you start with a cis reactant and you end up with a trans product, or if you start with a trans product you end up with a cis product. So those kind of dependence in the configuration of the reactant is very pertinent when you talk about the pericyclic reactions. Another important thing is the number of reacting electron pairs, or the number of conjugated double bonds involved, also affect these reactions. So the product description that you find with two conjugated double bonds won't be the case with the three conjugated double bonds. So it depends upon the number of reacting electron pairs or the number of double bonds that are there in the reactants. And then another thing is almost all of these reactions, they depend on their reaction conditions. Like some of the reactions are favorable to happen under thermal condition, and some of the reactions are favorable to happen under photochemical reactions. So photochemical means the influence of light, thermal means um, heat. And now heat, when I say, it doesn't mean you superheat a reactant, it can be room temperature also. Many of the reactions happen. Okay, so it can be thermal when you do not have any light presence, but rather it's just happening at room temperature. We classify them under the thermal reactions, and other reactions we will classify them under the photochemical reaction. So uh, when we deal with individual type of the pericyclic reaction, I'll be talking more in detail about the conditions involved and how the pericyclic reactions are very much having an effect of the thermal and the photochemical condition, and how the product varies depending upon the reaction conditions being used. Okay, so these are some of the common features of the various pericyclic reactions. So in the next video, we will be talking in detail about the theory that was actually used in order to explain the pericyclic reaction, and that is nothing but the conservation of orbital symmetry theory. Now, what that is, I'll be discussing in the next video. Thank you for your attention.